Okay, in this video we're going to convert from rectangular coordinates to polar coordinates. In other words, going from x and y to r and theta. So again, looking at our same image from the last video, we have polar and rectangular representations of any point in the plane. This time we're going to start with our x and y coordinates and convert them to polar coordinates. So we'll know what the value of x and what the value of y is. We're going to need to find the value of r and the measure of the angle. Well, to find the value of r, it's just Pythagorean theorem, x squared plus y squared, and then take the square root. For our angle of rotation, we can find a reference angle by taking the inverse tangent of y over x, and I use the absolute value here because this will guarantee that our reference angle is an acute angle. And then based on what quadrant our x and y coordinates happen to put us in, we can then either add or subtract that reference angle from either 0 or 360 or 180 degrees to find out the total amount rotated. Now, I do want to point out that, again, the theta prime is the reference angle used to find the total angle rotated. I do want to point out a key difference between rectangular coordinates and polar coordinates. So, for instance, this point right here in this picture has one representation in rectangular coordinates. It has a certain x value and a certain y value. However, with polar coordinates, because of coterminal angles and direction of rotation, the polar representation of this point has an infinite number of possible answers. Not only can r also be positive, but we could also r could be negative, and then it rotates a certain direction to get back to this point. So polar coordinates for any point in the plane, there's an infinite number of ways to represent it using polar coordinates. There's only one way to represent it using rectangular coordinates. So with that in mind, what I'm going to ask is I'm going to restrict you to only using positive values for r and only values between either 0 and 360 degrees or 0 and 2 pi radians for theta. So convert each of the following to polar coordinates. We have 2 and negative 2 square root of 3, which I plotted that point. It's in the fourth quadrant. So looking at our right triangle here, we can use Pythagorean theorem to get the value of r. So 2 squared plus, again, I just keep the negatives positives, simply because I've seen too many students mess up on the squaring a negative part. But when you do this, you get the square root of 16, which is 4. So this radius length is 4. So we'd start by going out 4 units, and then we're going to have to rotate beyond 270 degrees to get to this point in the fourth quadrant. So to find the reference angle, in other words, the measure of this angle as it would be in the picture if we used a protractor, we have to do inverse tangent of the absolute value of negative 2 square root of 3 over 2. That becomes the inverse tangent of the square root of 3, which is 60 degrees. So this is a 60-degree angle in the fourth quadrant. So that means that we would have rotated, we would have stopped 60 degrees short of a full rotation, which makes our angle of rotation 300 degrees, or 5 pi over 3 radians. So r is 4, which we got from Pythagorean theorem, and our angle of rotation is, in radians, 5 pi over 3. Part B, negative 3, negative 3. We're in the third quadrant. So let's find our value of r using Pythagorean theorem. We get square root of 18, which is 3 times the square root of 2. So we have to go 3 times the square root of 2 units. And then we're going to have to rotate, and we're going to be beyond 180, but not beyond 270. So our angle of rotation should be between 180 degrees and 270 degrees. So using theta prime, we'll do the inverse tangent of 1, because negative 3 over negative 3 is 1. That gives us 45 degrees for our angle, which means that we rotated 180 plus another 45 degrees. Our total amount that we rotated then is 225 degrees, or in terms of radians, 5 pi over 4. So our polar coordinate of this point with a positive value of r and an angle between 0 and 2 pi is 3 square root of 2 and 5 pi over 4. Part C, we have 0, negative 3. Here we can just again, because it's on an axis, we can just count how many spaces from the origin this point is. It's 3 units. We could do 0 squared plus 3 squared and take the square root of it, but I just think it's easier to look at the picture. And again, picture's worth 1,000 words here. We rotated 270 degrees to get this point. So our angle of rotation is 270 degrees, or 3 pi over 2 radians, which gives us our polar representation as 3 and 3 pi over 2 for the rotation. Finally, part D, we have -3 and 4, so we're in the second quadrant. So let's start with our Pythagorean theorem. We get a radius of 5. And our theta prime, we're going to do the inverse tangent of the absolute value of 4 over -3. And because we don't have 4/3 as one of our angles that is going to be in our chart, we can use an approximation here. We get 53.13 degrees, which means the total amount we rotated, we stopped 53.13 degrees roughly short of 180. So to calculate the angle rotated, it's 126.87. Now, in terms of exact answers, we have the 5 for the radius rather, but here we have pi minus the inverse tangent of 4/3. The inverse tangent of 4/3 is the 53.13 degrees. Pi in radians is 100, or in degrees is 180 degrees. So this 126.87 is 180 degrees, which is the pi, minus the 53.13 degrees, which is the inverse tangent of 4/3. So our exact polar representation of that point is 5, and then pi minus the inverse tangent of 4/3. All right, that about does it for this video. Thanks for watching. I'll see you next time.